Hello, I'm Markvist, and today I'm gonna present you a programming language I've been working with for a few game jams now. It's a video game development programming language that's made for scripting. So yeah, let's dive on. The language is called Grimoire. It's made by a friend of mine, so this is why I've been working with it a lot. Um, So let's dive straight away into the code and see what it looks like. So this is code that I've made during the last game jam that I've participated in. I put a link in the description for what this code is about in terms of video game gameplay, etc. So the programming language has a C-like syntax with most of the stuff delimited by curly brackets. Here we have a bunch of enums. Notice a pub keyword. We're gonna get back to that. The language supports some sort of object-oriented programming. It's not actually object-oriented. It's a little bit more nuanced than that, closer to Go. Actually, this language is heavily inspired by Go, so we'll see the Go theme quite a lot. So functions start with func, and so the function signature are a little bit strange among programming language. We have the argument list first, and then a return list, because functions can return any number of arguments. The limit being how much RAM you have. So let's see if I can find a function that returns several things. Not right away, but maybe I'll be able to. No, I don't think we have any such function that is obvious, but here you can see that here we call a function that takes that gets two return value, an x and a y value, because it's coordinate for the spawn of the boss in the stage. So this programming language is implemented in D version 2, and it's compiled into a bytecode, and then this bytecode is interpreted. Much like in C, functions are actually pointers to locations in the bytecode, which means that we can actually get an equivalent of a function pointer in this language. For example, here we have an array of function pointers. So you declare an array of function pointers that take nothing as an argument and return nothing, and start the array, and boom, we can make an array of anonymous functions pointers. There's no closures or anything of the like. So yeah. So let's over-analyze this language a bit and its syntax. We're gonna switch to something more handy for that. Here we go. So here we can see a number of pieces of information on the language. So the language is strictly typed. So whatever you instantiate, you're forced to give a type. Here we have a bunch of enum types, which are relatively strictly enforced. So we have this public keyword. Why? So everything is accessible while it is in the same file. But if you want to use stuff from different file, you have to use the use keyword. And only stuff that is marked public is accessible, including members of classes. So array access is very C-like. There's actually not a lot to note on everything here, except that the declaration of array types uses a keyword array. It's technically a keyword, creates a type for the array along with all of the associated functions of an array. So to get back into the code, we can see that this language has some form of method calling. Let's see if I can show you a nice example. Here we go. So here we can see that we are using the colon operator on map, which has the effect of calling the function with the map as the first argument. So it's not exactly object-oriented programming because you have no virtual dispatch and nothing of the sort, but you have something that looks, smells, and feels kinda like function calls, method calls. Notice that you don't actually need parentheses at the end of the method call. That is actually specific to method calls, that doesn't apply to functions, like here. So this language is relatively fast. It's faster than Python, which doesn't say a lot, but it's quite good. It's been made to replace some other languages in terms of video game programming languages that mean to control a lot of individual elements. And for that, this language has a form of concurrency. And this concurrency is tasks and events. So the main function of a Grimoire software program is called main. And this function is called whenever, like, it starts a coroutine that is the main function whenever it starts up. It doesn't need to. If main is not present, it doesn't start any coroutines. And you also have events and tasks. So events are actually tasks. So there's not actually a lot of difference between calling this an event or replacing this by task. The main difference that exists is that events are registered in the D host. So if you have an event, you can call it from the D programming language. While if you have a task, you cannot really call it from the D programming language. You have to call it from Grimoire. So tasks and events all start a coroutine upon being called. So right here, we see that we have a player task that we call immediately. This will instantly handle the player. Whenever the main is started, it will start the coroutine that handles the player. So it will add another coroutine to the scheduler. The language is single-threaded. Even if there's concurrency, there's no threads involved. It's just coroutines. This language also has channels, which we actually didn't use in this project. The syntax of channels is exactly identical to that of Go. For those who never did Go, channels are a way of transferring data between different green threads or coroutines or Go routines without actually having any form of concurrent access to the same data. Like, it's not technically supposed to be shared. You send it and you forget about it. Here, that's not exactly the case for certain objects, particularly objects that come from the debugging language, which are actually passed around as pointers. For example, in our case here, the enemies, like the boss, for example, that we can get from using the spawn boss function, is actually an object that is not programmed in Grimoire. It's programmed in D and has a bunch of functions that work on it, which allow us to interact with it. For example, here we have the enemy wait activate, which I actually wrote, I think. It's here, and takes any enemy, which boss is an enemy. So it handles the inheritance that is on the D side, thanks to using pointers. And we can do any operations that we could do on an enemy, like set active, or set position, or get position, I think. I think we do a get position at some point. Yeah, here, we do a get pos, which is the same. So yeah, keep in mind this is a game jam project. Some function actually are redundant. We have a get position and we have a get pos, because two people worked on the same thing at the same time, and we didn't fix it. So one of the points this language shines at is its integration with D. It's really well integrated, and for example, let's go into script here. It's possible to add a function and directly use this function. So we declare here a function that takes a geo call, because that's a signature that we expect from functions that are passed to Grimoire as primitives. And we specify the types that are accepted, and everything is handled for us. Beyond that, we can rename the function. We can also transmit enums as strings, and those can get translated to normal D enums, which we actually use a lot in this project. As you can see, we have a lot of enums. As you can see, we have different coding conventions, because we have some former C developers and some developers from C#, D, or myself, which codes myself in C++. So we have a lot of mixed conventions, which is not very good in general in the project, but when you make a video game in a week, that is to be expected that things don't get that organized. So yeah, I hope you found this video interesting, and I maybe see you later.